welcome to my class. I hope that you are all fine and great today despite of the situation. Just a reminder, always put your mask on whenever you'll go out. Wash your hands often, and as much as possible, let's all stay home and together let's beat COVID-19. While at home, we can still make use of our time learning new things. And today, we will investigate the relationship between volume and pressure at a constant temperature of a gas. And if you really wanted to maximize your time while at home, I invite you to watch it from here until the end. So, what are we waiting for? Let's get started. Ta-da!
Have you ever traveled from road to a hilly area? That is, to an area with a higher altitude? Did you carry a bag of chips with you? Have you observed that if you go to higher altitude, the bag of chips starts to expand? And at times they even burst? How does that happen?
Now, to answer this question, we must study the concept of Boyle's law.
Let us start with this simulation. Let's get to know first what's in here. We have a gas container, an air pump, a barometer that records the amount of pressure, and a thermometer that will measure the amount of temperature. In this setup, gas molecules occupy 1,000 units of volume, and the pressure inside the container is 5.29 atmosphere at a constant temperature. Since we will hold the temperature constant, this means that we will not vary the temperature. Now, what do you think will happen to pressure of the gas if we'll decrease the volume? Let's find it out. So, after decreasing the volume, we observe that the pressure increased from 5.29 atmosphere to 35.29 atmosphere. Now, what about if we'll increase the volume? What do you think will happen to pressure? Right, the pressure decreases. So what conclusion can we draw out of this observation? Very good! As the volume of the container decreases, the pressure inside the container increases. And as the volume of the container increases, the pressure inside the container decreases. And this is at a constant temperature. The relationship between volume and pressure of gases at a constant temperature was first stated by Robert Boyle during the 16th century. He concluded that the volume of a fixed amount of gas is inversely proportional to its pressure at a constant temperature. Now, what do we mean by inversely proportional? Inversely proportional refers to the relationship between two variables that when the value of one variable increases, the other decreases. That is, when we increase the volume, that the pressure will decrease, and that when we decrease the volume, the pressure will increase. Now, what if we'll decrease the volume by 1/2? Of course, we know that the pressure will increase, but the question is by how much? Let us again investigate using this simulation. To determine how much pressure will increase if we reduce the volume by 1/2, let's have a fixed amount of gas in the container, and let's hold the temperature constant. Initially in this setup, the volume occupied by gas molecules is 1,000 units of volume and with a pressure of 5.29 atmospheres. Let's now reduce the volume by 1/2. That is from 1,000 units to 500 units of volume, and observe what happens to pressure. Right, the pressure doubles. This observation is the same with what Robert Boyle observed in his experiment. Boyle observed that if the pressure was doubled at a constant temperature, the volume of the gas became half the original volume, and if the pressure was tripled, the volume became one-third of the original volume. As you see in this experiment, you have gas enclosed in a container. In 9 seconds, there are 9 heats, so there is 1 heat per second. And if the volume is reduced to half in the same time, that is 9 seconds, there are 18 heats, so there are 2 heats per second. Hence, reducing the volume of the container by 1/2 results to doubling the number of heats and the pressure. Let us explain Boyle's law using this diagram. Adding more loads on top of the container increases the external and internal pressure. Since pressure increases, this means that the gas molecules occupy a lesser volume. Remember, as the pressure increases, the volume decreases. Conversely, when we lessen the loads on top of the container, there will be a decrease of external and internal pressure. Since pressure decreases, this means that the gas molecules occupy a greater volume. Remember, as the pressure decreases, the volume increases. So now, did you find an answer to why does a sealed bag of chips expand? Or at some extent explode if you take it to higher altitude? Right! This follows the concept of Boyle's law. When we go to higher altitude, the pressure lessens. So when the air pressure outside the bag of chips is lesser than the inside, the air in the bag of chips expand, causing the bag to inflate and to some extent explode. In grade 9, your teacher probably asked you to make a long model to explain respiratory system. What do you notice as you pull the bigger balloon that represents the diaphragm? Yes, the lungs expand. This actually applies Boyle's law. Pulling the rubber balloon represents inhaling. As you inhale, the lung cavity expands, causing the pressure inside the lungs to decrease and become lower than the outside pressure. As a result, air flows from the higher pressure area, which is outside the body, into the lungs. Exhaling is the opposite process. When you release the rubber, which represents the diaphragm, the balloon representing the lungs decreases in volume. When the diaphragm contracts as you exhale, it results to a decrease in the lung volume, increasing the pressure inside the chest cavity and causing the air to flow outside of the lungs. Let us now check your understanding. Let's have question number 1. Each of the flasks contains the same number of molecules. In which of the following flasks the pressure is highest? If you answered flask 1, well done! Let us now move on to the second question. As the volume of confined gas decreases at constant temperature, the pressure exerted by the gas block. If your answer is increases, you got it! Let us now move on to question number 3. If a balloon is squeezed, what happens to the pressure of the gas inside the balloon? answer is increases. Well, congratulations! Let us now move on to question number 4. Assuming that the temperature remains constant, how can you increase the pressure? And if your answer is decrease the volume, you're great! Let us now move on to the last question. Which of the following describes the relationship of volume and pressure? And if your answer is inversely proportional, very good!